I didn't want to give you guys 3 notes papers in one day because that's kind of mean. So we're splitting it up. Today's a short day. We'll do a short lesson, short Alex, boom, boom, and we're out of here, all right? So a proportional equation looks like this. Good morning, guys. We briefly mentioned this yesterday. In the same way that every time I go to find k, I'm going to use the equation k equals y over x. Every time I write my equation, I'm going to use y equals k times x. All right? Where y is a placeholder for y values. A placeholder for y values. In pink, x is where you plug in x values. And k, as we know, is my constant of proportionality. All right, so in the same way that our equation k equals y over x, we know that k is the constant of proportionality, y is where all my y values would go, x is where all my x values would go. Wrong spot. There you go. You didn't write that at all. Exactly. All right. So that's my proportional equation. It looks just like that, right? Y is equal to kx. In our warm-up, if I look back at it, we found that k was equal to 4. So if I wanted to write the equation for this relationship, I would say y is equal to 4x. Right? That's my equation. So that if I was asked, say, how many quarters are there in $100, I could plug 100 in here and multiply it by 4. Well, what's 4 times 100? 400. So there are 400 quarters in $100, right? It's just simple multiplication. That's all it is. So that's a proportional relationship. That's what we've been working on, but what we're going to move into next week is a non-proportional relationship. Non-proportional relationship. And the equation looks very similar, except what's the only difference you see in this equation? Vanessa, what do you see that's different? There's no variable? Ah, yeah, there's another variable. What is that other variable? B. B. All right, if I cover up that plus B, does it look exactly the same? Yeah, y equals kx. It's the same thing. The only thing that's different is I'm adding a b value, and a b value is my y intercept. Okay, everybody say y-intercept.
Y-intercept.
Where have we heard the word intercept before? Cars? Football? Yeah, what is an interception in football? Amari, what does that look like?
When the opposite team catches the ball.
When the what?
When the opposite team catches the ball from the other quarterback.
Yeah, good. So, okay, let's stay focused, right? So if I'm the quarterback, Amari's my receiver, right? If I throw the football over to Amari and Jada jumps up in the middle and grabs the football, right? She just intercepted the football. So she got right in between it, okay? Thank you. Wait right here. So my y-intercept is the point in which my line, right? I'm going to have a line. It's where my line crosses the y-axis. So flip back for a second to yesterday's notes when we were talking about the number of hours of school and the number of school days, right? Is my y-axis going up and down, or is my y-axis going left and right?
Up and down.
My y-axis is going up and down. That's why it's pink. That's where all my y values are. And this line right here is my proportional function, my proportional relationship. Where does this black line cross this pink line? Where do they intersect?
The origin.
At the origin, right? Well, what's the y value of the origin? 0, 0. So when I have a proportional relationship, it's like y equals kx plus 0. Does adding 0 do anything for me?
No.
No. So that's why I don't need to include it when I've got a proportional equation. All right? So again, we're going to explore more about non-proportionals next week. All we're doing today is identifying which of these equations is proportional, which of these is non-proportional. So let's take a look. And just like the Alex yesterday, if they are proportional, then we're going to find our value for k. Okay? So if I look at this first one, y is equal to 1/2 x. Which of these two equations does this equation follow? The first one or the second one? So let's take a look. Y equals kx or y equals kx plus b. Which one does this look like? Y equals kx. Do you see any b value hanging off on the end? No. There is no b value. So this is proportional. What's my value of k for this equation? It's the only number in there, right? So let's go back to our equation. Y is equal to kx. My k value is always going to be attached right next to that x. They're going to be like glued together. So what number is glued to that x in this equation?
1/2.
1/2. That's my k value. 1/2. You guys see that?
Yeah.
Okay. Let's go down. This second one, y is equal to 2x minus 1. What do we notice about this equation right away? There's two numbers. There's a minus 1. If I have two numbers, right, two separate numbers, I know that this is not proportional, right? My b value here is -1, which makes this non-proportional. I'm going to just call it non-prop for short. Everyone see the difference between these two?
Yeah.
It's just that second number. That's literally all we're looking for. Yeah.
I can't read that like the orange.
The orange? Okay. Is that better?
Yeah.
Perfect. So this one says no B, and this one says B. Now let's look at this bottom one. All it says is y equals x. So think about it for a second. We're going to determine if this is proportional or non-proportional. I want you to give me a thumbs up if you think this is proportional, and a thumbs down if you think this is non-proportional. What do you guys think?
Wait, you said proportional is up?
Proportional's up, non-proportional is down. I want to see everyone. If you don't know, just take a guess. What do we think? Okay, ladies right here is saying up. Ooh, everyone in the back is saying down. Interesting. Ukamba's saying down too. If your thumb is up, you're absolutely right. This is proportional. Do you see a number being added? Okay. So here's why, right? What number is in front of that x? Is there a number in front of that x? No, but what number was is actually there? 1. Okay. What number is being added or subtracted after the x? Nothing. That makes it proportional. Thumbs up. Proportional, right? there is no b here once again, making this proportional. If it's proportional, then I can find my k value. What's my k value here going to be? 1. Right? So you may be like, oh, if I see one number, it's proportional. If I see two numbers, it's non-proportional, right? Well, this one didn't have any numbers. So as long as we remember that my x always has an invisible 1 in front, then we can use that kind of logic to understand it. Now, if I go up here, where am I? Right here. Negative x equals y. What about this equation is different from all the other ones? Ayana?
It's backwards.
It's backwards. And my x is negative. Good. So, in order to make this easier on my eyes, I'm just going to swap these around and say that y is equal to negative x. Can I do that with an equation?
No.
Yes, you
Man,
can.
Yes, you can. Equal signs go both ways, right? I could flip them around and around all I want. This is equal to that. That is equal to this. Either way, they're equal, right?
Yes.
So, y is equal to negative x. Is there a b value on the end?
No.
No, so I know right away that this is what? Proportional. Now, if it's proportional, I can find k. What? Well, very close. What number is in front of my x?
Nothing.
There is nothing. So what's the invisible number that's there?
1.
1. But there's something that's not invisible too. What is that?
Negative sign.
A negative. So my k value would be negative 1. All right? It's all right. Guys, relax, 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 relax. All right? It's math, okay? We're getting too worked up. Second one, y is equal to 2 plus 3x. Do I see a number in front of my x?
Yes.
Yes, what is that number in front of x?
3.
A 3. Is that my k value?
No. Yeah. No.
Yeah, no, yeah. There's a lot of mixed answers today.
Yes.
Okay, all right.
Y equals 2.
Who can tell me why 3 is not my k value?
No, I can't.
Vanessa, you got it?
There's another, oh wait,
Yeah.
there's another number.
Exactly. There's a b value, which makes this non-proportional. If it's not proportional, I cannot find a constant of proportionality because it's not proportional. Even though my 2 and my 3x are kind of in swapped spots, what I'm looking for is the number in front of x and the number that's away from my x. I know. I'm walking towards the phone. Yep. Yeah. Yes. Try the last one on your own. Try that last one on your own. See if you can figure it out. Is it proportional or not? Okay. Perfect. Yep. No problem.
Mr. Church,
Yeah.
I'm not sure.
Okay. Hold on. What do you think? Thumbs up, proportional. Thumbs down, non-proportional.
No.
Billy says non. Phaedra says non. Shanvir says non. Everybody says non. You're all right. Why is this non-proportional?
Because that's 2 numbers.
There's 2 numbers.
And it's flipped.
And it's flipped. Now the flip doesn't really matter. All we're looking for is that plus 4. That's my b value. Just like this plus 2 was my b value. So it's going to give you some flipped equations. And that's fine. All you need to be looking for is that extra number, that second number. All right? That tells me that it's non-proportional. If there is no second number, my k value is just the only number I see. If I see an x without a number, it's that invisible 1. If I see a negative x, it's an invisible negative 1. That's all we need to remember. All right? What questions can I answer about that? Quick show thumbs. How are we feeling about this? Thumbs up seems pretty easy. Thumbs sideways. I got to see the Alex first before I make a judgment. Okay. Okay, perfect. Let's do that then. Let's sign on to our Chromebooks and get started.